Welcome to 6-1 video lesson algebra 2. The concept here is roots and radical expressions. There's 6 boxes here to talk about, and I'm sorry that I sound like this, but when I'm making this video, I have a little bit of a cold, so that's why I sound like a monster. Okay, so box number 1, we are going to understand this word called roots. Some of this stuff is going to seem very, very simple, but I really want to understand the language that's being used here. And actually more, I want you to understand the language that's being used here. So let's do some stuff that we should probably already know. Okay, starting over here with 5 squared equals 25. What this means is, that 5 is the square root of 25, because it means that 5 times 5 gives me back 25. Or you ask yourself, what number do I multiply by itself 2 times to give me back 25? Okay, the second one here, 5 cubed equals 125. This we all know. What this means is that 5 is the cube root of 125. Or what number times itself 3 times would give me back the number 125? Okay, this one down here. 5 to the 4th is 625. What this means is that 5 is the 4th root of 625, because it means that what number do I multiply by itself 4 times to give me back 625. So the exponent has something to do with the type of root that we are using. So if I keep going, in general, what we can say is this, and this is a big important stuff here. It says if a to the n is equal to b, with a and b being real numbers, and n is some positive integer, then a is the nth root of b. Or another way we can write this is that a is the nth root of b. And I'm going to let you copy this down in just a second, but I want to show you some important facts here. So let me shrink this down. This is important, okay? Let's take a look at the number 2 to the 5th. 2 to the 5th is equal to 32. That means that 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 32 is the number 2. Let's take a look at this one though. 2 to the 6th equals 64. Well, 2 times 2 times 2 times 2 times 2 times 2 times 2 is 64, but also negative 2 times negative 2 times negative 2 times negative is also 64. So the 6th root of 64 is either 2 or negative 2, because they both give me back 64. So what I'm going to refer to is what's known as the principal root. The principal root is the positive one. So the principal 6th root of 64 is 2, even though there is technically another number, negative 2, such that we could multiply by itself 6 times to get back 64. We're going to refer to this one as the principal root. So this is the important part right here. So let me shrink all this down and give you a second to copy it in your notes. Okay, box 2 is all about the parts of radicals. So the number that sits on the outside of the radical, this part here, that's called your index. The actual physical sign that I'm tracing out in red for you here, that's called the radical sign. And the number that's underneath the radical sign is called the radicand. So as an example, this 6 is my index, this of course is my radical sign, and the number 11 is my radicand. Those are the parts of a radical. Okay, box 3, let's do some examples. Let's find all real roots of the following. So part A says the cubed root of 0.008. So what are we looking for here? We are looking for a number such that when we multiply it by itself 3 times, it gives me back 0.008. Well, 0.2 times 0.2 times 0.2 is 0.008. So therefore, the cube root of 0.008 is 0.2. Okay. If you didn't know that, you could use the calculator to figure it out. Part B says the cube root of negative 1,000. So again, what number times itself am I looking for to give me back negative 1,000? Well, my number has to be negative. So what number would it be? Well, it'd be negative 10, all right? So negative 10 times a negative 10, that's a positive 100. Positive 100 times a negative 10, that's a negative 1,000. So therefore, the answer here is negative 10. All right, that's the one we're looking for. That's the cube root. All right, and then if I go over here to part C, the cube root of 1/27. So again, this means what number times itself 3 times is going to give me back 1/27. So it's probably 1/3, right? 1/3, 1/3, 1/3. Let's check it out. What's 1/3 times 1/3? That's 1/9, right? What's 1/9 times 1/3? Well, that's 1/27. So therefore, this is 1/3. So 1/3 is the cube root of 1/27. -10 is the cube root of -1000. And 0.2 is the cube root of 0.008. All right, box 4 is examples. Let's find all the real roots. I've got 5 examples to talk to you about. So we'll do this in green, okay? So it's the cube root of -8. So this literally means, okay, what number times itself 3 times is going to give me back -8, -2, -2, -2. So another way to think about this is -2 all to the third gives me back -8. So therefore, the cube root of -8 is the number -2. Right? Part B says the square root of 0.4. So what number times itself gives me back 0.04? Well, that'll be 0.2, right? 0.02, 0.2. 0.2 gives me 0.04. So therefore, the square root of this is 0.2. Okay, part C says the fourth root of -1. So this means what number times itself 4 times is going to give me back -1. Let me move over just a little bit. Well, it's not 1, right? Because if it was 1, it would just be 1 times 1 times 1 times 1. So how about, let's try -1. -1, -1, -1, -1. Well, -1 times -1 is a positive. And then a positive times a negative is a negative. And then a negative times a negative is another positive. Shoot, that's not it either. So you know what? This one has no real roots. And the problem says find all the real roots. Well, that one doesn't have one, so I put a little sad face there because there is no number multiplied by itself to give us back -1 4 times. Okay, part D, the cube root of -27. So again, ask yourself what number times itself 3 times is going to give me back -27. Let's try -3, right? -3 times -3 is a positive 9. That's a positive 9. 9 times -3, that's -27, yeah. So this is -3. That works out great. This one's right up here. This one's over here. Okay, the square root of -49. So what number, again, times itself gives me -49? You probably guessed it doesn't exist, right? Because if I do 7 times 7, well, that's not -49. And if I do -7 times -7, that's also not -49. So this one has no real root. So we want to make sure that we are paying close attention to all of those and what the directions want us to do. Okay, box 5, this is you try. Find the real root to the fourth root of 16. Ready, set, go. Okay, hopefully you got the right answer of 2, because 2 multiplied by itself 4 times gives me back the number 16. Therefore, the fourth root of 16 is the number 2. Okay, box 6 is a very important box, and make sure you're paying attention. It is the nth roots of nth powers. So here's what the property says. It says for any real number a, the nth root of a to the n is going to be one of 2 things. It's going to be a if my n is odd. It's going to be the absolute value of a if my n is even. Let this sink in. So take a look over here. If I have the 5th root of x to the 5th, I get back x. And the reason I get that back is because the index and my exponent in my radicand match. Therefore, I just get x back. I just get this part back. Now, the 4th root of x to the 4th is going to be the absolute value of whatever I have left over because my index is even. Let's play this out in the following example here. I've got the 4th root of x to the 4th, y to the 12th. I want to create indexes and exponents that match. So how about the 4th root of, I'm going to call this x squared all to the 4th. Now let that sink in. Remember, if I raise a power to a power, I multiply them. So 2 times 4 is still the 8, so I haven't violated anything. And better yet, I have now created something where my index and my exponent underneath my radical match. That's good news. But I'm not done, because I can also write this as y to the third all to the fourth. Let me extend my radical. Again, notice that my index and my exponent match. This is good news for us. So let's keep going with this, all right? So this is going to mean that I can have the fourth root of x squared all to the fourth times the fourth root of y cubed. Oh, this goes on the inside, my bad. Excuse me. Y cubed all to the fourth. So I'm just breaking this down into little bitsy pieces. Now, let's take a look. Let's apply the rule, all right? Since my index and my radical match and n is even, this is going to be the absolute value of x squared. Since my index and my radical match, okay? Oh, what did I just do? Yeah, that's right. Then the fourth root of y cubed to the fourth, again, is going to be the absolute value of y cubed, because my n is even. Now, the absolute value of x squared is always just x squared. So I get x squared times the absolute value of y cubed. So now I have a simplified version of this. The reason that the absolute value bar is needed here is because it ensures that the root is always going to be positive, which ties back to that principal root at the very beginning. That's why you need that bar right there. The absolute value bars are not needed for x squared, since x squared is always a non-negative number. We're going to practice a lot more of these in class, so don't worry about it, but jot this example down.